Peace be upon you. Today we will talking about a new lesson, which is quadratic models. This lesson, which is related to quadratic functions, and we all know that quadratic functions are polynomial functions, where the highest power of x is 2. Okay, then here we have an example, which is this example, which is f of x equals a x squared plus bx plus c. And we all know that A is not equal 0, and A and B and C related or belonging to the real set, which is real set. And we know that the graph of the quadratic function is called a parabola. Okay. Okay. Then here we find this one, this parabola, which is quadratic functions, and we know the vertex, which is this point, and the intersections or x-intercepts, which is this point and this point. And about y-intercept will be this point, and it's related to C. Okay, let's find lots of different things. We have this main idea, which is the x-intercepts are the points where the graph, which is y, equals f of x, cuts the x-axis. Then they are also called the zeros of the functions because they are the x values where y equals 0 or f of x equals 0. Then we have this mean rule. And this rule is what? Is x equals negative v, positive or negative square root of v squared minus 4ac over 2a. For example, if I have this function, which is f of x equals 2x squared plus 3x minus 5, then a will be 2 and b will be 3 and c will be negative 5. And we can find the value of x by substituting, which is negative v, which is negative 3, positive or negative square root, under the square root, which is 3 squared, which is 9, minus 4ac. Then we know the c equals negative 5, and a equals 2, which is negative 5 times 2, it will be negative 10, times negative 4, it will be positive 40, divided by 2a. Then 2 times 2, it will be 4. 2 times 2 equals 4, and so on. This is related to what? To the zeros of the function, okay, which is the same thing. We can call it x-intercepts. We can call it what? I'm sorry about that. We can call it x-intercepts. Same thing, which is x-intercepts, the same like this one. Here we have the y-intercept. We all know that we can find out the y-intercept by putting x equals 0. Then here in this function, which is y equals 2x power 2 plus 3x. And instead of x, I'll put 0. Then 2 by 0, it will be 0. And 3 by 0, it will be 0. And the rest will be negative 5. Then y-intercept will be negative 5 in this case. Let's move on. Let's move on. Here we have the first example, which is plot the graph of f of x equals negative half x squared plus 7.5x minus 18. We can use Dismos, which is an amazing website, to draw this function. And we can find lots of things based on this website by using this one. Then I will write f of x equals negative half x squared, okay, negative 7.5x. Let me check this one. Yes, I'm sorry, it's not negative, it's positive. then positive 7.5, okay, minus 18. That will be minus 18. As we see this graph for our function, we can minimize, okay, to find lots of things. To find x-intercepts, okay, this is 3 and 0, 3 on x-axis and 0 on y-axis. And the next point, which is 12 and 0, which is we have the x-intercepts or the zeros of the function, which is 3 and 12. And we have the vertex here, which is 7.5 and 10 and 125,000th. Okay, what about y-intercept? Just only click on this function, then we will find y-intercept equal negative 18, which is the same c, the value of c here. And this is the answer for this question by drawing the whole function. One more thing, which is how can we find the y-intercept? By putting x equals 0. Then instead of x, we will put 0. Instead of x, we will put 0. We will find the final answer, which is y equals f of x, which is equals negative 18. Then y-intercept will be negative 18. Okay, let's move on. Here, y-intercept negative 18 and 3 and 12 are the zeros of the function, which is x equals 3 and x equals 12. And we find the vertex, which is here the whole definition of the vertex. The maximum or the minimum point of the graph of a quadratic function is called what? The vertex. Okay, came from this one. Okay. I think it's easy. What about our domain? Okay, we can evaluate. We all know that that domain related to the x-axis, right? Then the domain, the value of x belonging to the real set. And what about the range? The range of f is y belonging to the real set when y is smaller than or equal to 10 and 125,000th, which is this point here. You got it from the vertex. Then we find the range. Let's move on to find the line of symmetry of a quadratic graph that we call it the axis of symmetry. If the x-coordinates of the x-intercepts are x1 and x2, then the equation of the axis of symmetry is x equals x1 plus x2 divided by 2, which is the middle point, Here in the example 2, you can also use the formula above to find the equation of the axis of symmetry. Then find the equation of the axis of symmetry for the graph of f of x equals negative half x squared plus 7.5x minus 18. Okay, here we have the x-intercept, which are x equals 3 and x equals 12. Then from this equation, we can solve it directly. I think it's so easy, really. Then we know x1 and x2. Then x1 equals 3 and x2 equals 12. Then 3 plus 12 divided by 2 will be 7.5. And as we know, we can find the x-intercepts or the zeros of the function using a, b, c, which is x equals negative b, positive or negative, square root b squared minus 4ac over 2a. Using this rule, this law, we can find out the values of x-intercepts, the same thing. But we can use our graphic calculator, by the way, for the same issue. Thanks for watching our lesson for quadratic models. Don't forget to like and subscribe in my channel. And don't forget to like this video and share it. Thanks for watching.